All right, so today we are dealing with chemical kinetics, and it's a very interesting physical chemistry. So, yes, first thing we need to know about chemical kinetics is the branch of physical chemistry that deals with the study of the rates of chemical reactions with the elucidation or clarification of how the reaction proceeds. Now, when you hear the word kinetics, obviously the first thing that comes to your mind is rate. And over a period of time, we just come and say, okay, and rate. What exactly is rate? What is rate? Now, we know that chemical kinetics is the branch of physical chemistry that deals with the study of rates of chemical reactions with the elucidation. The word elucidation there also means clarification. So is either you say elucidation or you say clarification of how the reaction mechanism proceeds, or you say the reaction proceeds, whichever one suits you. Now the keywords there are rate, also chemical reaction, and clarification. I'm going to hammer on that clarification, meaning in as much as yes, you're seeing that okay, this is the rate at which this reaction is going, you also need to see the clarification of how the mechanism proceeds. Now, rate on its own, rate, when you talk about rate, you're talking about change in concentration. Talk about rate, you're talking about change in concentration over time, usually represented as d over dt. Now, the reason why I'm leaving that open space empty there is because obviously it can be any alphabet. Okay, for example, if we're dealing with a molecule or ion or atom, for example, an atom A. Now the rate of A would be equals to change in the concentration of A over time, which will now be represented as dA over dt. Now it's possible that we have a negative rate, and it's also possible that we have a positive rate. Now what can cause it? Is that if your for instance, let's say A is a reacting species. If the A is the reactant, obviously you know that at the course of the reaction, A will tend to decrease, and decrease in concentration of A will lead to a negative rate, while increase in the concentration of A, if for example A is a product, obviously A is going to be increasing. So increase in the concentration of A will lead to positive rates. Yes, that will lead to positive rates. Now, for example, where you have A plus B, for a reaction where you have A plus B equals to, for example, for a reaction where you have A plus B to give C plus D. Yes, when you have A plus B to give C plus D. Being that A is a reactant, like I just said now, it will decrease over a period of time. So the rate of A would be minus dA over dt. Why is it minus? Because A is decreasing over time. And the same thing for B. Because B is also a product, the rate at which B would react in that particular place, in that particular reaction, in this particular reaction, would be minus dB over dt. Why is it minus? Because B is a reacting species. But if we're talking about C, if we're dealing with C, the rate at which C will be produced. Now look at it. C is being produced. So because C is being produced, it would increase. And because it's going to increase, it's going to be plus dC over dt. Because C is on the increasing side. Now D as well will also be a plus. Why? Because D is also increasing. I hope it's clear. If it's reacting, obviously the concentration will be reducing, and when the concentration is reducing, it is regarded as negative. But when the concentration is increasing, it's regarded as what? Positive. That's just what rate is. Rate is also what? Change in concentration over time. But what then is rate law? What is the law that is guiding rate? Now rate law states that the rate of a chemical reaction is directly proportional to the concentration of the reacting species. Now let me rephrase this another way. It says the rate of a chemical reaction is dependent on the reacting particle only. On the concentration of the reacting particle, on the concentration of the reacting particle. which can also be written as rate directly proportional to concentration. But that's by the way. Let's take an example. We're going to take an example where X mole of A plus Y mole of B is going to give us C plus D. So let's assume that we have X mole of A and Y mole of B as a reacting species. Now remember, I said the rate of any reaction, of any chemical reaction, is what? Is dependent on the reacting species. So we already have our reacting species to be what? A and B. But we are talking about X mole of A and Y mole of B. So rate is directly proportional to concentration of reacting species. Although rate, when you want to remove the proportionality sign, you now introduce a constant K. So rate is equals to K open bracket concentration of reacting species raised to power the mole of that concentration. I forgot to add that part, so make sure you put it. So it's basically rate is equals to K open bracket concentration of the reacting species raised to the power of mole, raised to the power of number of mole of the reacting species, which you see in the next page. Now, if we're looking at the rate at which A reacted in that equation, if we're looking at the rate at which A reacted in that equation, that is in the XA plus YB, it will give us C plus D. The rate at which A reacted, I can either say the rate at which A reacted or I say the rate at which A disappeared. So the rate at which A disappeared is equals to minus the A over the T equals to K in bracket A raised to power X times B in bracket raised to power Y. Because what? The rate is dependent on the concentration of A and B, and they have to be raised to power their mole. Now, the rate at which B also reacted, or should I say the rate at which B disappeared, is also minus the B over the T. Why is it minus? Because B also disappeared. B is also decreasing. So the rate at which B is decreasing is minus the B over the T equals to K open bracket A raised to power X B into bracket Y raised to power Y. So what this means is that what this basically means is that the rate at which B is decreasing is still dependent on A and B. Now, the rate at which C will be produced is also still dependent on A and B, but the expression is written as plus. Why is it plus? Because C is increasing. We're looking at the rate at which C is increasing, that is being produced. So that's dC over dt equals to K open bracket A raised to power X close bracket open bracket B raised to power Y. Now, the rate at which D was produced is similar to that of the rate at which C was produced, which is also K A raised to power X B raised to power Y. Now, the reason why A and B are reacting species, and the rate of chemical reaction is dependent solely on the concentration of the reacting species. Now, that's it. The rate of chemical reaction is solely dependent on the concentration of the reacting species. Now, we have order.